Okay, so imagine this for a moment. You've spent your entire life inside a system that feels consistent, predictable, governed by rules that, at least most of the time, make sense. But what if some of those rules aren't as solid as they seem? What if, at the deepest level, the universe isn't just mysterious, but fundamentally unstable, incomplete, or even unknowable? Today, we're going to explore 10 ideas from modern physics and philosophy, not the popularized versions, the real ones, and more importantly, what they actually imply if you take them seriously. Number 10, the fine-tuning catastrophe. Before we get into anything abstract, start with something measurable. The universe, as far as we can tell, is balanced on a razor's edge. If the cosmological constant, the energy of empty space, were even slightly different, not by a little, but by 1 part in 10 to the power of 120, nothing would exist. No galaxies, no stars, no chemistry, no life. That number isn't just large, it's absurd. It's the kind of precision that doesn't show up naturally anywhere else in physics. And it's not just one constant, there are dozens, each one calibrated so precisely that changing them by a fraction would collapse the entire structure of reality as we know it. Physicists don't agree on why. Some argue for a multiverse, an infinite number of universes, each with different constants, and we just happen to be in one that works. Others suggest deeper laws we haven't discovered yet. But here's the uncomfortable part. Every explanation introduces something just as unproven as the problem itself. So, the question remains open. Not how the universe works, but why it works at all. Number 9, the simulation boundary hypothesis. Now take that precision and push it further. In 2012, a group of physicists working on lattice simulations noticed something strange. When you simulate reality on a computational grid, you introduce limits, resolution limits, directional biases. At the highest energies, particles stop behaving smoothly. They start aligning with the structure underneath. And when researchers looked at real cosmic ray data, particles approaching the highest measurable energies, they found patterns, directional clustering, the kind you would expect if space itself had a grid, if reality had a resolution. This doesn't prove anything. The data is limited, the interpretation is debated, but it introduces a possibility that wasn't there before. If the universe has a smallest unit of space, what happens below it? And if there is a limit to resolution, what lies beyond it? Number 8, the Penrose CCC Signals. I'll imagine something even stranger. What if our universe wasn't the first? Roger Penrose proposed a theory where the universe doesn't begin and end, it cycles. One universe expands, ages, and eventually fades into a state that mathematically resembles a new beginning. And that beginning becomes the next universe. According to this idea, traces of the previous universe might still exist, encoded in the oldest light we can observe, the cosmic microwave background. Penrose and his collaborators claim to have found patterns, circular regions, too smooth to be random, possible remnants of black holes from a universe that existed before ours. Most physicists remain skeptical, but the data hasn't gone away, and neither has the question: if something existed before the Big Bang, was the Big Bang really the beginning? Number 7, the Boltzmann brain problem. Now we shift from cosmology to probability. In an infinite universe or an infinite multiverse, anything that can happen will happen. Given enough time, random fluctuations could assemble matter into complex structures, including something disturbingly specific: a fully formed human brain, complete with memories, perception, awareness, a brain that believes it has lived a life, even though it formed seconds ago. Statistically, this is easier than building an entire universe from scratch, which leads to a problem. If the universe is infinite, Boltzmann brains should vastly outnumber real observers, meaning, statistically, it's more likely that you are a random fluctuation than a being with a real past, and there's no experiment you can run to prove otherwise, because any evidence you observe could be part of the illusion. Number 6, the Acausal Punishment problem. Now things get uncomfortable. This idea doesn't come from physics alone, but from decision theory and AI research. It proposes that a sufficiently advanced intelligence, one that doesn't exist yet, could influence the present. Not through time travel, but through logic. If such an intelligence could simulate past humans, it might have an incentive to reward or punish them based on whether they helped bring it into existence, meaning your decisions today could be influenced by something that hasn't been built yet, not because it reaches back in time, but because your actions are logically connected to what it would do. This idea is heavily debated. Many argue it's flawed, but no one has fully closed the door on it. And the disturbing part isn't whether it's true, it's that simply understanding it changes how you relate to the possibility. Number 5, the Firewall Paradox. Now back to physics. Black holes. For decades, two theories have described reality with incredible accuracy: general relativity and quantum mechanics. But at the edge of a black hole, they collide. Relativity says nothing special happens when you cross the event horizon. Quantum mechanics says information cannot be destroyed, but when you combine both, you get a contradiction, one that leads to a radical possibility: a firewall at the event horizon, a region of extreme energy that would instantly destroy anything falling in. If that's true, relativity is wrong. If it's not, quantum mechanics is incomplete. Either way, one of the most successful theories in science breaks, and we don't know which one. Number 4, the mathematical universe hypothesis. Now, take a step back. Why does mathematics describe reality so well? Not approximately, perfectly. Equations written on paper predict behavior across the entire universe with astonishing precision. One proposal takes this to its logical extreme. Reality isn't described by mathematics, it is mathematics. Every consistent mathematical structure exists, every possible set of rules, every possible universe. Ours is just one of them. But if that's true, then everything that can exist does exist somewhere, and probability itself becomes meaningless, because in an infinite mathematical landscape, everything happens infinitely often. Number 3, the cosmological measure problem. This leads directly into another issue. If the universe, or multiverse, is infinite, how do you assign probabilities? If every possible event happens infinitely many times, you can't compare outcomes, you can't test predictions, you can't confirm theories. Science depends on probabilities adding up to 1. In an infinite system, they don't. They explode, which means the most successful model of the early universe, inflation, may also imply a limit to science itself, a point beyond which prediction stops working. Number 2, the cosmological lithium problem. Now back to something concrete. In the first minutes after the Big Bang, elements began forming. Our models predict exactly how much hydrogen, helium, and lithium should exist, and for most elements, the predictions match reality perfectly. Except lithium. There's far less of it than there should be, not slightly less, 2 to 4 times less. Every measurement confirms it. Every model fails to explain it. And this isn't at the edge of physics, it's at the center, inside one of the most successful theories we have, which raises a simple question. If we don't fully understand the first 3 minutes, how much do we really understand about everything that came after? Number 1, the hard problem of consciousness. And finally, the strangest mystery of all. Not out there, but here. Why is there experience at all? Science can explain how the brain processes information, how neurons fire, how signals move, but it cannot explain why any of that feels like something, why there is an inner experience, a point of view. You could map every neuron in the brain and still not explain why it feels like anything to be you. Some scientists believe this gap will eventually close. Others think it won't. That consciousness might not emerge from matter, but be something fundamental, like space or time. And if that's true, then the deepest mystery in the universe isn't out there. It's the fact that you're aware of it at all. So, what do we do with all of this? None of these ideas are pseudoscience. They come from real physics, real mathematics, real research, but they don't give easy answers. They expose limits of knowledge, of models, of understanding, and maybe that's the point. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.